Hi guys, in this video we are going to learn another interesting question from kinematics of particle. However, in the previous video also we have discussed an interesting question. If you haven't watched it yet, just I have given the link in the description so you can always watch that, because I have already told what are the equation you need to memorize before doing this question. So if you haven't watched, please watch that. After that only you can easily understand this also. So I'm not going to repeat those old theory areas over here. So if you don't know, just read those questions and answer. So here we are going to discuss an easy question in the way. However, there's a little bit change than the previous question. So what's the change over here? Before that, if you are new to this channel, don't forget to subscribe it. Yes, we can read the question. So I'm going to read the question now. Just jot down the points. After that, try it in your own. And finally, compare your answers with mine. So, okay, let's read the question. The motion of cutting tool B. So this is a cutting tool. Don't consider my drawing. It's nasty. Okay. The motion of cutting tool B is controlled by the robot arm O, A and B. I haven't marked the A, so we can just put it over here. So O, A, B as shown in this figure. At the instant shown, the arm rotates anti-clockwise at uniform angular speed. Omega, which I have marked as theta dot, is equals to 15 revolution per minute. So just consider the units also. And the length of portion AB decreases at the uniform rate. So we have given that the length of the AB is going to decrease at a uniform rate. So just consider that. So I have already mentioned that this is a uniform angular velocity, as well as this rate is also uniform. So just consider that. So after that, they are telling if the length of OB is at the instant is 500 millimeters. So note that when the instant, if the length of OB is 500 millimeter, determine the velocity and the acceleration of B. So it's not a big deal. However, you need to remember those equations. Why am I doing this simple question? The idea behind this is, in the previous question as well as in the equation also, we have taken the equation at the radial direction. However, in that radial direction, it's not towards the velocity, it's not towards the center. However, in this question, we are going to see this V towards the center. So it's not a big deal. However, when we are considering the sign of the values, we will get negative for some values. So I'm going to do this because here we will get some negative values too. If we consider that radial direction, when we are talking about the radial direction, we normally consider along that direction, along that radial direction. So in this one, so when we are considering the V in the opposite direction, which means towards the center, we are going to put as negative. So that's the only difference we are going to see in this question. So just pause the video and try it on your own. After that, watch the rest of the video. So here I'm going to mark the equation first. As I have already mentioned, when you are doing the equation or questions, just write the equation you have already learned. When we are considering those equations, just I'm going to mark it as VR. The radial velocity would be R dot, as well as when we are considering about the V transverse velocity, it would be R into theta dot. So when we are marking the next one, AR radial directional acceleration would be R double dot minus R theta dot squared, and the A transverse direction acceleration would be R, sorry I have forgotten, R theta double dot. So it's better to write always and again, so you can easily remember those. So 2R dot theta dot, these are the equation. When you substitute the values, you will get the answers. However, just concern about the negative signs also and the directions also. When we are considering this equation, when we are deriving this equation, we have just used the radial direction and the transverse direction, which means in the radial direction means we are going to take in this, along this axis, along this OB, which means in this direction. Also, when we are considering the transverse direction, it would be in this direction. Because it's going to rotate in the anti-clockwise, we can directly tell if we use the right hand rule. So if we use that, we can directly tell it's going to be in this side. So these are the main direction we have taken. So when we are considering the VR over here, so the question is we need to find the velocity at some instant. So I have missed that. Yes, when we need to find the velocity at OB at 500 millimeters, so I have already marked that. So it's going to decrease, however we need to find that. So when we are considering the VR radial velocity of this, as they have already given, this is a uniform velocity towards the center, which means opposite direction to radial direction. So just note that. So if we are doing that, if we are solving this, we need to use negative signs. Why is that? We have derived the equation in the radial direction, but here it's in the negative direction, which means opposite side. So we need to change it as minus. So radial directional velocity would be minus 200. Be aware with these units. However, I'm going to mark it as millimeter per second. But if you like, or if the question asked to find that velocity in the meter per second, so you need to change that to minus 0.2. However, the main thing is, as if you are going to tell us VR radial directional velocity, just keep in mind you need to put this minus. Otherwise, if you use this direction and just putting this B, and if you're going to use that, you can directly tell B is equals to 200. That's not a problem. However, if you are going to use the radial velocity, which means in this along the radial direction, just consider this negative sign. So this is the main reason I have doing this question. Okay, let's continue that. So when we are considering the VT, it would be R into theta dot. So here, what's the radius, what's the length of OB? So when we are considering this, we have already given that we need to find that in 500 millimeter. So I'm going to just write it as 500. So, and we need to find the value of theta dot. We already know that theta dot is equals to 15 revolution per minute. So I have already told that when you are using this and substituting for that, you need to consider these units. Because here they have given in revolution per minute, so we need to change to radians per second. Otherwise, we don't get the answer in second, because there is a minute as well as revolution. So we need to change to radian per second. It's not a big deal for you. So 15, which means 15 revolution per minute. For 1 minute, we can write it as for 1 minute it's 15 revolution. So I am going to change this to radius. So as we all know, the 1 revolution, which means a 1 rotation, would cover 2 pi radii. From that we can directly tell if there is 15 revolution, we can directly tell it would be 15 into 2 pi, which means 30 pi. It's not going to over because there is a 1 minute. But here if we change to seconds, it would be 60 seconds. So this is radian. This is 60 seconds. So if you simplify this, you will be getting pi by 2 radian per second. So I'm going to substitute this pi by 2 radian per second. However, we have already noted this is in the millimeter. It's not a big deal. So we can directly tell 500 into pi by 2, it will be 250 pi. And millimeter per second, just note it down. So we have found the values for that. So the next point is we need to find the AR for and AT. That means radial direction acceleration as well as transverse direction acceleration. So when we are considering these, they have also given, I already noted in the last previous question also, which means what that is. They have given that this is the uniform angular velocity, as well as in this question they have given this is the velocity is also uniform, constant. So if they given like that, we knew that r dot is equals to minus 200, a constant. So if we differentiate that, r double dot would be 0, because if we differentiate any constant, we will be getting 0. Likewise, if we differentiate theta dot again relative to t, we are getting theta double dot, which is equals to 0. So here, if we consider this, we are going to get these two components 0. So I'm going to just cut it down. So if I'm marking this AR, it would be minus r into theta dot squared. So here the r is 500 millimeter, theta dot we have already find pi by 2, so pi squared by 4, and you can simplify that, get the answers. But be careful, you will be getting a minus answer. Also, when you are considering about the AT, you are getting 2 into r dot into theta dot, but here we have already know that r naught is also in this minus, but theta dot is plus pi by 2, so here also you are going to get in the minus side. So why is that? Just check that. So when we are considering the radial directional acceleration, as we all know, here there is no acceleration towards we are having the acceleration component towards the radial direction. However, the only acceleration force is r theta dot squared towards the center. What's that? What's that component? Yes, you can figure it out. It's centripetal acceleration. So as we always know, as there are no acceleration along this velocity, as it is a constant, we can directly tell there is only one acceleration component along the radial direction. It's going to be centripetal acceleration, which means it's going to act towards the center. But I have already mentioned, when we are considering the radial direction for any instance, it would be along the radius, but as it's inside, it means it's towards the center, we can just check it's going to get the negative sign. Also, when we are considering the AT, transverse direction, so here the acceleration is in this side. Why is that? The main thing is, we already knew that when it's rotating in this side, also there is no theta double dot, because theta double dot is 0 because of the theta dot, which means the omega is 0. Then why we are getting the deceleration in this side, which means acceleration in this side? The reason is this velocity towards the center is going to be constant. However, the velocity change in the radial direction caused this Coriolis component. 2r dot theta dot is caused by the velocity of 200 millimeter per second. What's that? Just watch any theory videos, because when we are proving this equation, the transverse direction acceleration, we will consider the velocity change along the transverse direction as well as radial direction. The radial direction component would be r theta dot, and the 2r dot theta dot is the component, acceleration component in the transverse direction, which caused by this velocity. However, the direction is going to change, so we can directly tell the 2r dot theta dot is going to be in this side. So it's not a big deal. If you substitute the value, you can directly get the answers. But just remember, when you are considering the AR or AT in the transverse or radial direction, be aware about these negative signs also. However, if they asked any absolute values, it's not a problem. So I hope this video would be useful for you. If you have any doubts, just comment it below. Thank you for watching.